Hi Joshua, let's
Hi.
do this another problem on the application of Newton law. Cooling curve. The temperature T in degrees Celsius of a cup of hot coffee as it cools to room temperature can be modeled by the equation T is equal to 25 plus K small letter a raised to negative T, where T is the time of cooling in minutes and A and K are constants.
So we
Uh,
have some of the data.
in tabular form.
Alright. So the first question is express the equation in a form suitable for drawing straight line graphs. So the form suitable for a straight line graph is again y equals mx plus b. So in order to get that form, we need to do a lot of modifications. T equals 25 plus K, 8, and negative 4. So T equals 25 into right. So if I take the natural or common logarithm on both sides, there will be this 25 that will be on the other side, and we can do anything about it. And it will not result in this form. So it's not dead end. So we can just move this t minus 25, and then take the natural logarithm. Then for this again, products, when you take their logarithms, those are the sums of the logarithms of the factors. Then we have ln k, then this minus a minus t will go on to the will go on into the real world, not from its exponential form. Okay, so now we can identify this as y since t is variable, and then we can also identify this as b since k is a
You can
constant.
put there.
Okay, put the tiny letter.
In red. Can you red?
Y, this negative pt is actually a variable. Yeah.
It
So
varies. The value varies. Yes.
this is not the x, although we can put this plus x, and then ln a is a constant, so we can put n. So we can rearrange some stuffs. So that's from the left side. Ln t minus 25 equals negative ln a t. When you actually there's a better convention. Uh, by convention, if you're doing a logarithm, this is supposed to be small a. Any logarithm, you need to put parentheses around it if you want the next variable to be on this side, because it will cause confusion. Okay, so now we have expressed the equation in a form suitable for drawing a straight line graph.
Is there any other equation that you can use?
There we can actually
Alternative.
we can although although it will be a little harder and
Just for
inconvenient, we
no,
can
don't change. Just keep them. We can just write on top or anywhere else. So
we can change all of
those who
these
want to learn, yes.
ln's with lg's.
What is
Well,
LG?
lg is the common logarithm. The common logarithm, the ln base is e, but for lg its base is just 10.
Okay, so can you write the LG formula? So for those who are trying to learn is how to solve problems like this, it would be a great help for them.
There.
Yes.
Also a reminder, lg would be substantially harder, although it doesn't matter as well. It's an alternative formula, this LG form. So draw the graph using suitable scales and use it to estimate the values of A and K. So actually, I've already prepared the graph. I'll just bring it out.
Ready to draw on
Excel spreadsheet.
on the Excel spreadsheet.
Actually, it's not Excel spreadsheet. It's just LibreOffice.
LibreOffice, which is
So we can see here
analogous to the Excel spreadsheet.
on the
Libre means free, right?
yeah, also it's library. So
Libre in
4
Filipino means free.
yes, 2468. These values on the A column, those are the X values for the graph. So that is just T. And then for the B, oh, actually, I actually named the formula LGT minus 25. I'm actually kind of sorry for that. This should be LN. Wait, maybe I can. I can change it as now. Unfortunately. So on this B column, these are the Y values, which is LN T minus 25. So these are the data points, and this is strand 9. This is the equation. I'll just try and select the equation there. So it's our equation. Except the G should be replaced with an N. Maybe there's a typo or something. Okay, so this is our slope and this is our y-intercept. Those will be needed for later use. So while I'm here, I'll just input them in my
What
calculator.
is the model for a calculator? You can show me.
Yeah.
It's a scientific calculator. This is
Yes,
sufficient to solve problems like this.
FX991EX. Right, so I've inputted them into our calculators. Time to move on back into our whiteboard. All right, so we've already drew the graph actually. It just requires us to draw the graph, so I'll just say this a check. But we now
Estimate the value of A.
yes, so we now actually have to estimate the value of A and T. So I'll just put a tiny letters again. This one, like constitution. So this is our M, this is our B. So earlier we saw that our slope is approximately negative 0.0809. And then our y-intercept is approximately
The computer can
alright.
hold
The y-intercept is approximately 1.8177.
charging.
So maybe the easiest one we can calculate as of now is B first. Is K. So for K, we can calculate K by just raising this all to using the exp function. Raise e to the power of this. 1.8177 1. So say T is approximately 6.1. So I got one of them. Now we just have to take down A. So for A, it's a negative, negative ln A. That's what so let's take the negative on both sides. Now we have this. And then again, e raised to this 0.0 equals we mistake territory, we should not use equal signs digitally. Here, if you just approximate it. Got both A and B, so we can now proceed to the next problem. Use your graph to estimate the time taken for the temperature to reach 37 degrees Celsius. So, here, T is the temperature. So we need to approximate how long, how much T is when how much little T is when big T reaches 37. So this is our equation. Just copy it, and then T minus 25 equals negative. Okay. So we need to find out what T is when just substitute directly. When T is 37. Just to make sure and see. Okay, good. We already know the values of A and K. So we can substitute it, and then I'll just substitute it. Wait, there's a slight mix-up. Okay. So actually, I forgot. Big T is temperature, and little T is time. Okay, I think that's necessary to remember. T is temp, little T is time. Okay. So ln 37 minus 25. 2.4 something. There's no more room to write down. So A equals, this also is oh, I can't actually input the answer because I have to do it manually. The values. So maybe we have to take a trip to the Excel spreadsheet to see. Ah, you have found it. Yeah, we did it. We found the final value. There's an outlier apparently. Good. Here, we found the 50. Good. Continue produce values to the calculator. Okay, now we can continue. Right. T is equal to 9.121 minutes.
What happened there?
Save. So, apparently in the graph, for some reason, the stored value that I entered was in LG10, which is the LG. That's weird because I input LM. Maybe Excel got confused.
LibreOffice.
Ah yeah, the LibreOffice got confused. They're adjacent to each other in the menu.
Yes.
I also wanted to point out here to use everything. So the balance got a little messed up. That's because when I solve the calculator, I'll just input this again. Nice. Got the good values now. All right. Train's back on track. So now we have to estimate the room temperature. So you might think, how do we do this? We have to find what happens after an infinite number of seconds or something. Actually, we need to do something like that. In order to find the room temperature, you need to estimate. You need to estimate what T will be when T approaches to infinity. I wrote 8 for some reason. Approaches infinity. So the proper notation for that is what is T going to infinity T. So in order to picture that, we need to initially go here first. So if we can see, I'll just this equation will be actually useful. I'll just use a different one. T equals 25 plus Ka to negative 2. What happens when T goes to infinity? So negative T will go extremely negative. Extremely negative. So what happens when something is raised to something extremely negative? Well, if you can just try it if you try it on your calculator, just 99 to the negative 100. Usually your calculator will just display 0. That's how small it is. So imagine if it goes to negative infinity. When T approaches negative infinity, this one will just be reduced to this one will just be reduced to will just be not just negative T, but this entire term, hard to see. This term will just be 0. So eventually we'll just be left with T equals 25 when T approaches infinity. So I'll just put this where it belongs. So T minus 25 up T equals 25 plus 8 to negative T. So this one will become 0. So then we're just left with T equals 25. So it is reasonable because most countries, most temperate countries and some of the tropical countries, their room temperatures approximately 25. And in chemical chemical uh, chemical standards, T equals 25 degrees Celsius actually the standard, so it makes a lot of sense. So we see if there are any other problems.
Yes,
Can we do that? There are no more.
Okay, so will you be able to estimate the initial temperature of the cup of coffee?
Oh, the initial temperature, bonus
Yes,
question.
can you go to the next page?
I'll just put the bonus again.
Or,
Bonus.
the-
Estimate.
the
Actually, wait. I'll just leave the text so it will be faster. Estimate
the initial
the initial
temperature of the cup of hot coffee.
temperature temperature
Of
of
the cup of hot coffee.
so it will be just 9 then just right. So initial temperature. So we're talking about finding T when no time has passed. So T when T was equal to 0. So let's see again what happens here. So apparently this is not
Just
K.
yeah, transfer the
This is not
and make
KA.
the argument. Then
Yeah.
you can transfer the equation as well.
I can transfer it unfortunately. So KA, let's put this completed. KA to the negative t. This is not like this. There's no parenthesis around it. But when t equals 0, this just simply disappears and turns into 0. When a raised to the 0 will just turn into 1. So
Put them all. So those for the other students who want to learn.
how do I put
Put
them
all the
all?
steps so everything will be clear.
I'll just put t minus 25 equals ka negative t. When t equals 0, this disappears and turns into ka to the 0, which just turns into k. K times 1. So t is simply 25 plus k. But I think we already know what k is. What's k? 66 is k. K is 66. So 25 plus 66 is 91. That's also
25 to 66. Put all the steps for all our students who are watching.
so
So
it
that
is
will
also
be the
reasonable.
initial temperature of the cup of hot coffee.
And is it? Yes.
Well done, son. Well done, George. Thank you for sharing your knowledge
Right.
about the linear law.
I hope all of you may have learned something, learned a lot of things. So bye. Thanks for
Bye.
watching.
Bye.